Hello there, fellow flight nerds. This is Ben Johnson from FlightNerdAirForce.com. Today I wanted to answer a few questions from an interested fellow flight nerd about some aerodynamic questions. But before we get into that, I just want to make a quick mention. I have a free video available on my website right now called The 10 Most Powerful Tricks to Achieve Your Pilot's License Dreams and Share Your Flying Passion with Your Loved Ones, all without blowing your budget or wrecking your relationships. If you find that to be a helpful topic that you would like to learn more about, you can visit the link near this video and click on that link, and it will take you to that video where you get to learn some of that fun topic and hopefully very helpful information for you there. So today, one of the questions I had from somebody is, on an airplane, where should the center of thrust be in relation to the center of mass or the center of gravity of the airplane? And where is the center of lift typically on an airplane? That sounds like a pretty involved question. I love this question because I love aerodynamics. And so it sounds like this person is interested in developing an airplane or designing an airplane and is curious to see how the relationship of the different parts and structure of the airplane relate to one another. So we're going to talk about that today. In order to understand this, it's really important that we take a half a step back and talk about stability of an aircraft in flight. There are four primary forces acting on an airplane at any given time. And those are, obviously, number one is gravity, or weight is another way to see that. Gravity is always pulling down on the weight of the aircraft. The other one that works in opposition to that is called lift. Lift is the force that pulls the airplane up off of the ground and keeps it in the air, obviously. And it works in opposition to gravity. Thrust is the force from the propeller that pulls the aircraft forward. And it works in opposition to something called drag. Drag is the force created by the wind blowing over the aircraft, rubbing up against the aircraft, blowing over the control surface of the plane, and banging into the just the structure of the airplane itself, and in a sense creating a backward force that thrust has to work to overcome in order to keep the airplane moving forward. So these are the four main forces that are acting at all times on any airplane in flight. Now, in order to keep a plane flying in a stable condition, if we wanted to just look kind of like this airplane looks in this picture here, flying straight and level, not climbing, not descending, but also stable in the sense that the pilot doesn't have to be constantly adding corrections to the control yoke in order to control the plane. The stability of an aircraft is the tendency of that aircraft to return to its original flight condition. So if you started off in straight and level and then you turn the yoke to the right, the amount of stability of the airplane is the tendency of that airplane to return back to straight and level flight. Now, on a trainer aircraft like the Cessna 172 in the picture, we want to have a very stable aircraft. We want it to be maneuverable enough such that it's not hard to maneuver and get it to do what we want, but we want it in general to be a pretty docile aircraft. We want it to return to the position that it started out in order to make it a more safe aircraft and an easier aircraft to be able to control and fly, because we're largely using these for training new pilots and for just enjoying simple flight. We're not cranking, banking, we're not flying upside down, anything like that. So aerobatic aircraft, on the other hand, are typically pretty unstable. They're harder to fly in the sense that you have to control it. You have to be hands-on controlling it all the time. So stability of the airplane is important to know where we want the center of thrust of an aircraft to be. So if we're going to design our own airplane, how do we design the plane such that thrust is moving in the right direction in relation to the center of gravity of the plane? All those sorts of questions. So I'm going to let you in on a little bit of how, like a Cessna 172, like this aircraft, would be set up to make it a very stable airplane. So on an airplane like this, our center of gravity, or our center of mass, is generally going to be someplace just forward of the wing, or very close to the leading edge of the wing. And what we mean by the center of gravity is it's sort of a mathematical point on the airplane where if you added up all of the force of gravity over the entire surface of the whole airplane, mathematically, where is most of the weight of the aircraft centered? Where is gravity acting mathematically in one single point on the whole aircraft? I hope that it's like the average of all the force of gravity of the whole airplane. Another way to say that is if we can think of the airplane like a teeter-totter, the center of gravity is the point where if we tried to balance the airplane on a fulcrum like a teeter-totter, the center of gravity is the point on the plane at which if we balanced it on that fulcrum, it would not tip up, nose up or nose down. It would balance there perfectly, just like that. And it's important to know where that center of gravity is because in flight, if that center of gravity gets too far outside of a safety envelope, we're going to end up with the plane trying to fly nose high or nose low and creating some very difficult situations, very dangerous situations. On the other hand, in relation to the center of gravity, we also have the center of lift. And the center of lift is often someplace around here, someplace very close to the spar line of the aircraft, near the beginning of the near the front of the wing, near the leading edge of the wing. And it is the center of lift is just like the center of gravity. It's a mathematical point where if we added up all of the forces of lift acting on the wing, mathematically, where are they concentrated at the most? In other words, where is the average place where lift is acting the most on the wing? And it's a mathematical point. And on a plane like this, what we often have is the center of gravity. Again, gravity is the force pulling down. Our center of gravity is acting right here, and it's pulling in a downward direction. And our center of lift is pulling in an upward direction. Now, as you can tell, these are not in the same place. There is a distance between the center of gravity and the center of lift. They're not right on top of one another. So what's going to happen is we're going to have some counteracting forces here. We are going to have this center of lift pulling up in a place that's aft of the center of gravity. And what we kind of have then is a force that is going to try and twist the airplane into a nose low sort of circumstance. It's going to end up pushing the nose of the aircraft in a downward direction. And that's not a good situation. You don't want to have to be constantly pulling up on the yoke in order to fly straight and level. So what we do in order to counter that, or what the designers of the aircraft do in order to counter that, is they do something back here on the horizontal stabilizer that will help counteract that nose downward force that's happening between the difference of lift and gravity, center of lift and the center of gravity. And what they do is when they physically bolt the horizontal stabilizer onto the airplane, you can't really see it here, but it actually has a little bit of a tail up direction. The leading edge of it is down just a little bit, and the trailing edge of it is up just a little bit. Now I exaggerated that red line in order to show you sort of how it looks, but it's only a couple of degrees. It's not very much at all. And what that tendency does then is it then pushes, because it's up like this, as the wind passes over here and bounces off of it here, as the wind passes over here. What it does, that wind passing over there forces this tail down. And so what we have now is the force up by the center of gravity pulling downward on the plane, the center of lift pulling up, and then to counter that center of gravity pull, we have a downward force caused by the angle of attack of the horizontal stabilizer. So now what we have is two downward forces that equal out the force of lift. And those two counteracting downward forces, both in front of and behind the center of lift, give that aircraft a lot of stability. It gives it the ability to return to the original position in which it was after you stop adding input through the control yoke. I hope that helps you understand a little bit about the stability of an aircraft. In the next video I'm going to talk about how the center of thrust and the center of lift and gravity all play into how you want to have these things set up on an aircraft in order to have a safely operating aircraft. Again, if you like this information, there is more at my website, www.flightnerdairforce.com.